Hi everyone and welcome to the first lab of CS210. This is going to be a hands-on introduction to VHDL. So what is VHDL? VHDL is one hardware description language. Okay. So it's a language for describing hardware. So let's begin with the motivation for VHDL. Why does such a language exist? Why do you need a language for describing hardware? Suppose you wanted to describe this circuit to somebody else. Let's say to a teammate who are designing another part of a circuit. Okay. The obvious way would be to share a diagram, right? A diagram of this kind, which would show what are the connections between the components. But suppose you wanted to describe a more complicated circuit, such as this. Okay, this is a very fairly complicated diagram. A human who is interpreting this diagram could easily make some errors, right? So you need a representation that can be read also by a computer. Also notice that in this image, if you were to draw these gates horizontally instead of vertically, it would be a different image, but it would be the same circuit, right? So you need some way to describe or compare two descriptions, right? So obviously a diagram is not a good enough way to represent a very complex circuit. So modern processors have billions of gates, okay, lots of components connected in very complex ways. So you need some way of describing large complex digital circuits. Okay. So VHDL is a hardware description language. That's what HDL in VHDL stands for. And the purpose is to describe hardware. Okay. In a way that is unambiguous. There is only one clear interpretation. This is the most important. This description should be understood by both humans and by computers. So suppose you describe this hardware in a way that can be interpreted by computers. It would be useful if a tool such as a simulation tool could simulate the behavior of the circuit. This would be a useful thing, right? So you could design circuits and try them out by simulation before actually manufacturing them. Okay. Also, such a hardware description language can be used by synthesis tool. So what is a synthesis tool? Typically, let's say you can describe a circuit at different levels of detail. For example, you could describe an adder such as C is equal to A plus B, okay, where C is some 8-bit number and A and B are also 8-bit numbers. This is a high-level description. A synthesis tool could take such a description and convert it automatically into a circuit for implementing the addition. Okay, a circuit using gates and so on. So this is called synthesis. So we need a language for describing hardware, in particular digital circuits, that can be interpreted by both humans and computers. So VHDL is one hardware description language. So very important is to understand that VHDL is not a programming language. Let's take a programming language like C or C++ as an example. These languages tell the computer what to do in a step-by-step manner. These are sequential languages. For example, declare some variables, assign some values to the variables one by one. Right? So these languages tell the computer what to do. But VHDL is more of a modeling language. It tells what is rather than what to do. Okay. So for example, imagine a language for describing the architecture of a house or a building. You would describe where there is a wall, what are the windows, how many windows, what are the sizes of the walls and so on. So it is describing what there is rather than telling the computer what to do in a step-by-step manner, right? So it's a modeling language. Okay, although it's a powerful enough language, it can be used like a programming language, but that is not its purpose. Okay, it's a modeling language. It's a language to model hardware. So let's jump to a quick example of a VHDL description. So this assumes that you have basic familiarity with digital circuits already. Okay. So let's say we want to create a half adder. A half adder is a circuit which adds 2 bits. bits A and B. So the maximum is 1 1, so that's 2. This is the result. So let's call this carry and this call this sum. So here's a quick truth table. So this is 0. Okay, here the sum is 1 and there's no carry. Again here the sum is 1 and there's no carry. So this is the circuit, and if you examine this, the sum is true only if only for these input combinations. This is clearly an XOR, and a carry is 1 only when both the bits are 1. So this is clearly an AND of the inputs. So this is a half adder circuit. So you have two bits, the sum is a XOR and the carry is a AND. Now what we want to do is we want to describe this in VHDL. So here is the VHDL description. If you see, it's a language, it's a text file, just like in C or C++, it's simple text which can be read by humans. There are two parts. Okay, so let's call this half adder. Half adder is a name, can be anything. This is the name I have chosen, and the names for the input ports and the output ports I have chosen as A, B, S and C. Okay, so if you notice, this VHDL description has two parts, this part and this part. Okay, there is entity half adder is, then I describe these ports, end half adder, and architecture behavior of half adder is, here I describe what the behavior of the half adder is. Okay, so take a moment to go through this code. Okay, so VHDL stands for this hardware description language. This in turn, VHSIC, stands for very high speed integrated circuit hardware description language. Okay, so it was originally designed by the US Department of Defense for documenting the behavior of digital circuits. So for example, you have a vendor selling you a circuit. You want the vendor to specify exactly what the circuit does in a very unambiguous way. That was the reason this language was developed. Okay, and it later on became an IEEE standard, found widespread use. The most common standard that people use is IEEE 1164, which was published in 1993, and there are several other revisions now, which are modern revisions of this language. So you are encouraged to quickly browse through the Wikipedia page for VHDL to know more about the history of the language and so on. So let's go on. So first of all, VHDL is not the only hardware description language. We have Verilog, which is very widely used. It's a major competitor of VHDL. We have Able, System Verilog, which have now been combined into one standard. And System C is based on C++. It's a library on top of C++. Alright. So the most important thing in a VHDL description is the entity block and the architecture block. So when you want to write a VHDL description, first think of the hardware that you want to describe. This is my half adder circuit. So first think about what is the name of this circuit and what are its interfaces. What are the input ports? What are the output ports? So in this circuit there are two input ports, 2 bits and 2 bits output, sum and carry, right? So the entity block enclosed from entity name and end entity name describes the interface and the name of the entity. So it just tells what is the name and the interface. So this particular entity has 2 input ports of type bit and 2 output ports, sum and carry, which are output ports of type bit. And then we have the architecture block. Architecture behave of half adder is, this describe what is inside or what is the behavior of this entity. So this entity block describes what is the interface, and the architecture block describes what is inside this entity or what is the behavior of this entity. Okay, so entity describes the interface Okay, the names of the ports, their types and so on, and the architecture describes the behavior. This has been divided into two parts because a single entity, say you might describe an interface, and then you might actually have different architectures, architecture 1, architecture 2 and so on, and you may use whichever architecture makes sense when you are actually creating this entity, right? So you may describe multiple architectures for the same entity. So if you are familiar with any other programming language like Python, C or C++, not C, sorry, Python or C++, this concept of an entity is similar to a class. Okay, you define the entity once, you define what the entity is, and then you can create many copies of it, many instances of the same entity. Let's say this name is AND gate. You can create object A1 of type AND gate, object A2 of type AND gate, and so on, and connect them in your final design. So it's similar to a class, and these are the objects of the class. Alright. So in this description of the half adder, this is the entity block and this is the architecture block. Okay. So a very important thing about VHDL is that it's a concurrent language. So VHDL statements are concurrent. Remember, this is not a programming language. It's not telling what to do step by step. It is describing hardware. So in this example, this XOR gate and this AND gate exist simultaneously, right? They are not one after the other, or they are not in sequence. They both exist at the same time. So if you look at these two statements that describe sum, the signal S is assigned the value A XOR B, and C is assigned a value A and B. So this symbol is called signal assignment. On this side is a signal. Signal could be something like a wire. You can imagine signal to be a wire. So S is assigned A XOR B. Now these two statements are concurrent. That means they exist at the same time. This is not to be done one after the other. They are both at the same time. Okay. They are not sequential. Unlike a statement in C or C++ which says A equal to C plus D and A equal to A plus 1. This is executed first, this is executed second, next, and so on. But there is no such thing in VHDL. I mean, there is, but by default, VHDL statements are concurrent. These two statements are concurrent. Okay. So that's the very important difference between VHDL and another programming language that you may be familiar with, like C, C++. Okay. So let's be familiar with the VHDL syntax, a few features of the syntax. This will come in handy when you're writing your own descriptions. So VHDL is not case sensitive. So a variable name such as foo, and all these three mean the same. VHDL does not care about the case, whether it's uppercase or lowercase. All these three will be interpreted to mean the same thing. So you cannot have one variable called a and another variable called small a. They would be the same thing. Okay. So take care to use proper names. So white space such as space and tab are ignored. VHDL uses a lot of semicolons, just like C or C++, and the semicolon is used to indicate the end of a statement or a block. Okay, a lot of beginner errors that you will see is the compiler complaining about not having the semicolon in the right place. Okay. Then VHDL has blocks, right? Blocks denote particular block. The block begins with keyword begin and end usually. Okay, just like C uses this curly braces to denote a block. Okay, and a block can in turn contain multiple statements or declarations. So if you see, for example, there is architecture begin and end, and within this the architecture is described. Okay, Notice that there are semicolons at the end of each of these statements, but not here for is. There is no semicolon here. Alright. So what about the names? Okay, so we used a name called half adder. This is an arbitrary name, but if you want to give a name, the identifiers can contain only letters, digits and underscore. I'm sorry, there's a typo here. Yeah, and the name must begin with a letter. You cannot have a name like 1, 2 and gate, for example, or underscore and. This is not allowed. They can only begin with a letter. Okay, and comments begin with 2 dashes. For example, this. So in this lab we are going to use the reference ebook called Free Range VHDL. This is a freely available ebook, okay, available at this URL. It's an excellent book with lots of examples. And for simulating the circuits that we described, we are going to use a free browser-based platform. Okay, you just need a web browser such as Google Chrome, and you don't need to install anything. It's called EDA Playground. Okay, it's located at this URL. This can be used for a lot of other languages like Verilog, System Verilog, and so on. Okay, so we are going to focus on only on VHDL in this lab.